Hello, hello, Triga Jarnigan here doing the essay questions for exam 3 of Principles of Physiology. So number 1 of our question, this is question 1 for this video. It is describe the action potentials in cardiac ventricular muscle and in the SA node. During each phase of the action potentials, describe the channels, ion currents, and membrane potentials involved. Part 2 of this essay, explain the ECG tracing and how each of the P, QRS, and T waves are made. Perfect. So let's go over that first part, which is the cardiac ventricular muscle and the action potentials that come with that. Scrolling up in my notes. All right, so we have our little visual. This is going to be the electroactivity of your heart, the membrane potential of it. Down here at 90 is our resting membrane potential. Cardiac cells have a higher resting membrane potential, a more negative resting membrane potential than our skeletal muscle cells. And so we will start here at our very polarized portion. So we're going to go through steps 1 through 4, 1 through 5. There are 5 steps, 5 distinct steps that we can really look at. So our first one is going to be right here, 0, depolarization. And that's essentially where, so our voltage-gated sodium channels are going to open, and that's going to cause an influx of sodium ions, and our membrane potential will rise from -90 to about +20, right up here. So this depolarization is how we get started. Sorry, just moving things around. Still going through it all. All right. And so, if I could find my things, gosh, sorry. I mean, I guess it eats up time. All right. So our depolarization, and it's going to go up through step 1 up to +20 in millivolts, and we're going to call this number 1. And number 1 is going to be our initial repolarization, and this is where the sodium channels will close, and then the potassium channels will open briefly and allow the potassium ions to leave in each cell of the heart. And this will cause a dip in the membrane potential, which we can see here. And this is going to start repolarization. This portion right here is called the plateau. We're going to label it number 2. This is going to be the next phase. And this is unique to cardiac cells because calcium channels will open, leading to an influx of the calcium ions, but the potassium will continue to exit. And so this influx of calcium will balance the leaving of the potassium, and it'll create this plateau and maintain this membrane potential near 0 millivolts, or MV. I think it stands for millivolts. Anyways, that is our next step. And then we'll come into here. I need to use that area. So this is 2 right there in our plateau. And then 3 right here is going to be our repolarization. This is where our calcium channels will close, and then more potassium channels will open and allow more potassium to flow out of the cell, and this will lead us to fall back down to -90 in millivolts, our resting membrane potential right there. I'm getting used to the camera still, sorry. And then we'll come back to where we were before, step 4 or step 0. We're back where we started. And this is where we return to our resting state, and it's going to be maintained by our sodium-potassium pump. It's going to keep it right there at our -90 for the next action potential. And I think that's about how it goes. So let's go to the next portion of that question. The SA node. So this also happens inside of the SA node. So talking about the SA node, we will have a slow depolarization phase due to funny currents. And these are caused by sodium and potassium ions leaking into the cell very slowly. It takes a lot of time for those ions to leak in there and be able to cause anything, and this slow rise in membrane potential will eventually bring it to the threshold that we need in order to get our heart to beat. The SA node is our body's pacemaker. It helps the heart beat. It does the good things for us. So there's that. It follows essentially the same phases that our heart does. When it comes to action potential, there's going to be a depolarization. Once that threshold is reached, once enough ions have flowed in and out of the SA node slowly. And I say slowly, but it's not really that slow. It happens pretty quickly. But it happens gradually rather than all at once. You know, the channels are, instead of being closed, they're open just enough to let some ions go through. I feel like I need to explain that well. So we're going to go through our depolarization, and that's going to cause our change in calcium once we hit our threshold. And then our membrane potential is going to rise pretty sharply. After that, there's going to be some repolarization. The channels will close and the potassium channels will open, and that will lead to potassium leaving, and that will repolarize the cell back to its resting membrane potential. So let's move into our next portion, part 2 of this. Explain the ECG tracing and how each of the P, QRS, and T waves are made. Okay, get down to this portion. Gosh, you would think that I would have it ready to go, right? Incorrect. There it is. I think. Nope, I was wrong. Sorry. I'm keeping all this in there. I don't like to edit my videos raw, unfiltered. I should start an actual YouTube channel. I've been thinking about that actually. Don't know what I would do, but you know, it's something to do at home. So, All right, into our ECG tracing. So this is going to be our electrical activity of the heart, and it's going to be a summary of it, you know, showing the big movements in electrical energy. And just like the question asks, there's a P wave, there's a QRS portion, and a T wave. So starting, we're going to be drawing this as well. Just follow along as I try to follow along as well. Our P wave is going to correspond to the depolarization in the atrium of the heart, and that is initiated by our action potential from the SA node. As this depolarizes, the electrical activity is going to be captured as our P wave. That's what that is. Atrial depolarization. All right. So let's go ahead and draw that portion. It is going to look, let's see if I can do this while I show you. Just like a bump like that. And that is going to be the start of our wave. Oh, gosh. My notes are finicky sometimes. It really boggles my mind. All right, so after our P wave, there's going to be the QRS complex or the QRS portion, QRS wave. And this is our ventricular depolarization, when the ventricles of the heart are going to depolarize. That SA node conducting that current all the way down through the heart. And this is a rapid sequence of depolarization through both ventricles. And what we were talking about earlier with our depolarization and repolarization of the cardiac cells, this is going to correspond to phase 0 and phase 1 that I showed you. So that resting membrane potential and then that steep depolarization as we go from -90 to +20. So this is going to give us a large, sharp wave. Gosh. I love technology. a large sharp wave where we will see a dip, and that is going to be our Q down here, P and Q, and then it's going to spike up and back down. That is going to be our R. Gosh, make fun of me all you want. I'm still stupid. All right, and then it's going to go lower than the Q when we form the S right there. Just like that. So that is the ventricular depolarization. And that helps us to, if we understand them correctly, it helps us to diagnose different heart conditions that can be present in a person. And then we will move into our T phase, and our T phase is our ventricular repolarization. Did I say that? Yes. Repolarization in the ventricles. And this is phase 3 of our previous drawing that we did, when it's coming back down sharply back into our repolarization, and this is going to be a resting state as we form this wave. It's going to come back up and have a little steep bump and then continue on, and that is going to be our T wave. So those are all of the waves. Let me double check that I've covered everything in this video. P, QRS, T waves are made. all right, that is going to be video 1. Thank you for watching. Video 2 through 5. We have 5 videos to do this time. Bomber. All right, see ya.